Hey everyone, this is Tony Verbsky here for your very last lecture of the semester. It's polar equations and graphs. So 11.6, polar equations and graphs. Well, here's the deal. We're not imaginary world anymore. We're in the XY plane again, right where we were before. First day of class. And yes, we're still plotting some point xy. And yes, we're still in trig. So x equals r cosine theta, because cosine theta is x over r. Y equals r sine theta. And of course, theta ref is what it's been for the last three sections, inverse tangent absolute value of y over x. And r squared is x squared plus y squared. But here's the difference. R is plus or minus the square root of x squared plus y squared. A negative radius does exist in this realm. But this realm is the real realm. It just kind of coincidentally works. So it's just a different way of plotting points. So what we're going to have to do is create some point, some theta r. So we're going to plot the exact same points, but we're going to use radius as angles instead. So let's see what we can do here to get through this section. So let's try. Oh, I like this book. Scratch that. We're going to plot radius comma theta. Not that it really matters. So let's do an example of point plotting. Now we could plot two 30 degrees, where this is r and this is theta. We could radius 1, radius 2, turn and burn 30 degrees. Right there, that's that point. But x equals 2 cosine 30, y equals 2 sine 30, which is 2 the square root of 3 over 2 into 1/2, which is the point, the square root of 3, 1 in xy world. So if you go over 1.7-ish, square root of 3, up 1, same spot. What was easier? Well, I think this is easier, as long as somebody provides kind of some circular gridded paper. It'd be awesome with all the 30s and 45s and 60s on it. It's actually called polar paper. We can go to the internet. Oh, let me see. Polar paper. Polar graph. Here we go. Paper. Ah, there we go. Isn't that cool? So the 30s and sometimes multiples of 10 are marked, and it's just regular XY grid. You got to remember, you're still in the XY plane, so you can always just go get this paper anytime you want. I like just drawing my own circles and my own fake angles. It's a little easier. Now, watch this. Here's an example. We have to tell you what a negative radius is. 2 pi over 3, which in my realm, don't tell anybody. I'm a degree person. So what we do is we turn and burn 120 degrees, and you measure 1 unit, 2 unit, 3 unit, 4 unit, boom. Nope, that's wrong. That's actually 4 comma 120. Turn and burn 120, measure 4. If you want to do a negative radius, you turn and burn 120, and then you pull the opposite direction. So you go 1, 2, 3, 4. So another name for this would actually be for whatever this angle is. So 120 plus 180, 300 degrees. Now you can rename it again. Heck, you could go like this. For negative 60 degrees. Or you could do really dumb and call it negative 4, just add 360 to that. 480. So it has like a billion names, but it's how you plot points. Here's another example, no biggie. They say go 5, negative 45 degrees. So you turn and burn negative 45, and then you measure 1, 2, 3, 4, 5. You know, another name for it could be 5, 3, 15. The stupid one would be negative 5, 135. You know, so turn and burn 135 and then measure backwards. Not a lot of fun. You could come up with a few more names, I'm sure, if you really wanted to. So, and by the way, x equals 5 cosine of negative pi over 4, and y equals 5 sine of negative pi over 4. Cosine, nope, even disappears, so it's 5 radical 2 over 2. Sine, you rip it out, minus sine, 5 sine of pi over 4. That's this. It's over 5 radical 2 over 2, down 5 radical 2 over 2, if you're looking for x, y's. Just two different ways to plot the point. So, let's take a look at some graphs here. Here's our equation conversion. Let's just start. So if I give you x squared plus y squared equals 4, you know that's a circle of radius 2. Because x minus h squared plus y minus k squared equals r squared is a circle with center hk, r equals radius. So there's that. Now, it's kind of hard to graph a circle on your TI-83, you know what I mean? Because you got to go y squared equals 4 minus x squared. Then you got to go y equals plus or minus the square root of 4 minus x squared. And then you got to grab your calculator and you got to go y equals, ooh, let's go shut all that stuff off. Shut it 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 off. No way I'm taking that out till after the final. No way. All right. So the square root of 4 minus x squared. And now I'm going to show you a trick. Just go minus Bayes' function y1. And then if you zoom 6 it, dumb, because it's minus 10. See, there's the upper part, the lower part, but the scale's too big. We can zoom in, I bet. All right. Now it looks like an ellipse, but you need to square it up. Zoom 5. There's the upper part, there's the lower part. Took me a while to graph the circle. But you got to remember, the other realm still exists. You're here. You haven't left. This is the beauty. Now, there's other ways to plot points, but there's a similar equation. Now, all you got to remember is x equals r cos theta, y equals r sine theta, theta ref equals inverse tangent absolute value of y over x, x squared plus y squared equals r squared, r equals plus or minus the square root of x squared plus y squared. Oh, x squared plus y squared is r squared equals 4. Therefore, r equals plus or minus 2. Now, you're going to love this. Mode. Switch it to polar. Now, let's work in radians. I feel better in radians, actually, when I work in polar. But now when you hit the y equal key, look, r's come up. Let's first try 2. And let's go graph. Look, it's a circle. I didn't even need the -2. Let me see if I can adjust this a little bit. R, let's go window. Theta step, let's slow down the steps, 0.05. Let's hit graph. See how you get a smoother circle if you adjust the step and it goes slower? Let's go y equals. Scooch to the right, hit enter, hold, hit enter. There we go, line with circle. See how it's tracing a circle in counterclockwise direction? But it is graphing the whole circle, and you didn't even need the other equation. So if you would graph both equations, look what happens. -2. Let's just bold this one. See, it starts in a different place than it did, still counterclockwise, but you know, it traced right over it. So you only need one. So technically, polar equations are awesome. This got x's and y's and numbers, and you got to memorize, do some work to get to it, where this easily translates into here, and you don't even need the negative radius. So this equation here is way simpler than that equation. So now graphing circles has just become easy instead of hard. Now, y equals x minus 3. I already know what this looks like. 1, 2, 3, slope 1. I don't need to be better. I really don't. I love this thing. Now, let's try to convert it. Now, we know y equals y equals r sine theta, x equals r cosine theta, minus 3. Bring it over, r sine theta minus r cosine theta equals -3. Factor out an r, you get sine theta minus cos theta equals -3. Now, you see, we want r by itself, just like when you got y's, you want y by themselves. So r equals -3 over sine theta minus cosine theta. Disgusting. It looked better before. Right here. Don't convert it. That'd be dumb. But we can convert it, but why would you make it worse looking? Would the calculator graph it? Most likely. Let's see what happens. -3 divided by parenthesis sine theta minus cosine theta. See how it puts thetas for you right away? Let's delete that. Oops. Let's go up here. Clear. And I don't know. Yeah, it's a line. So let's go zoom 6. Whoa, it graphed it, but it like double, triple traced it. That's just crazy. You didn't even need theta running from 0 to 2 pi. I think we could have just maybe did it in pi. Oop, that was still too much. Maybe we could have done it within pi over 2. But anyway, it's harder. So don't do that. Now, there are some fun things here. Like, what about r equals 3 sine theta? You could cheat. Like, what does this look like? And this is cheating. You just go 3 sine theta and you go, hey, verb, I don't know what it looks like. Let's fix our window. 2 pi. Now, it's going to be running between -3 and 3 because sine bounces between -1 and 1. So how about let's just graph it. So it looks like it's kind of a circle. Let's zoom in. Let's go up a little bit. Um, let's zoom square. Oh, it's definitely a circle. So it's a circle. Radius equals, I think, 1.5. The center is 0, 1.5. So that's a good equation. I didn't know it was a circle. But here's what I wish. I wish there was an r there. Because r sine theta is y. So let's multiply both sides by r. Now r squared is x squared plus y squared equals 3y. Whoa. I still like this equation better. Now this is where I get to say recall. And you get to get mad at me because you forgot how to do this. This is called completing the square. So you take the middle term times 1/2, you get -3/2. You save that number, you square that number, you get 9/4, and you add 9/4 right here. Now you just can't add 9/4 to the problem check out front. Yes, I added 9/4, so you add 9/4 to the other side to keep it in balance. So you get y x squared equals y minus 3/2 squared 9/4. So you take the same number. If you multiply that out, I promise you get this right here. And this, oh, this is a circle where the center is 0, 3/2, where the radius is the square root of 9 and the square root of 4. Oh, oh, what's easier? I'm going to just stay right there. I don't understand it, but I'm going to rather work in this realm. By the way, it gives you the same graph. It's just working with r's and thetas instead of x's and y's. Even though I don't feel comfortable, why would I work with a harder equation? Here we go. We're going to have some fun now. Now, everybody and their mother wish there was an r here. So let's multiply this side by r and this side by r. So r squared equals r plus r cosine theta. R squared is x squared plus y squared. R is plus or minus, but you found out that the minus doesn't matter. So let's just go like that. Hey, let's put the plus or minus in there. X. Whoa. This is not good. I don't know what this looks like. I never graphed one of those before. You know what? I'm going to stay here. And I'm going to make myself a little theta r table or r theta. Now you just pick the nice angles, like 0 degrees. Cosine of 0 is 1, and 1 plus 1 is 2. Now, 60 degrees is good, because cosine 60 is 1/2, so I get 3/2. 90 is good. Cosine 90 is 0 plus 1 is 1. 120 is good. Negative 1/2, therefore 1/2. 180 is good. Cosine 180, negative 1, you get 0. 240 is good, because that will be negative again, just like the 120, so 1/2. 270 is good. Cosine of 270 is 0, so 1. 360, whoops, no. Let's do the 300. Whoa. It's positive again, so you get 3/2. And then 360, you have to get 2. Now you're in the XY plane. We can draw these little, here's a circle of radius 1, here's a circle of radius 2. And we can draw our 60, here let's do them dashed. 60 degrees, 0 degrees, 90 degrees, 120 degrees, 180 degrees, 240 degrees, 300 degrees. Okay. Now you turn and burn 0. Here you are. You measure 1, 2. You turn and burn 60, and you measure 1.5. You turn and burn 90, and you measure 1. So this thing is coming around like this. Turn and burn 120, and you measure 1/2. You turn and burn 180, and you measure 0. You turn and burn 240, and you measure 1/2. Turn and burn 270, you measure 1. Turn and burn 300, you measure 1.5. Turn and burn 360, and you made this cardioid. Cardioid. I think it looks like an elephant butt print. That's just me. Have I ever studied elephant butts? Nope, haven't ever graphed them before. So looks like Polar's good for something, graphing something called a cardioid, or in my case, an elephant butt print. So I definitely don't want to study this. We'll study this, because I didn't even like studying hyperbolas. This is going to be way worse. So I'm staying right here. Now, it's cool because now instead of circles, hyperbolas, ellipses, exponentials, lines, now you have cardioid functions. Pretty awesome. Cosine 2 theta. There's 3 formulas for this. I'm going to go with cosine squared theta minus sine squared theta. And I wish I had an r squared and an r squared. So I'm going to multiply by r squared and multiply by r squared. So I get r cubed equals, I'm going to just bring in the r squared. So r squared cosine squared is x squared minus r squared sine squared is y squared. But this is r squared r, which is x squared plus y squared. R is the square root of x squared plus y squared equals 3x squared minus 3y squared. And I don't want to study that. So let's just work with r equals cosine of 2 theta. Now you could make a theta r table, or you could cheat on your TI 83. 3, what is it? 3 cosine 2 theta. Window. 0 to 2 pi, window, 0 to 2 pi, ready, set, graph. Whoa. Zoom, let's trig it up, zoom 7. Woo! This is called a 4-leaf rose. Have we studied 4-leaf rose? Leaved. 4-leaved rose. Or 4-leaf rose. Either way. What I like doing though is when I'm graphing it, I like slowing it down so I know where it started from. 05 it. I like to put the line with the ball. So it starts there. And I want to make sure that it took the full 360 degrees or 2 pi to graph. Please stop right there. Pretty cool. So you needed the full 360 degrees or the full 2 pi, 0 to 2 pi to actually graph it. Now that would be a lot of point plotting to actually get that, and you'd have to, really put a lot of thetas in here if you wanted to. Good enough. Now, you can graph r squared equals cosine 2 theta. That puts us into this situation again. Now, do you need to graph both? Well, you need to check because you're not used to working in this realm. All right, let's try zoom trig. All right, let's zoom in. Pretty cool. The infinity symbol. Let's shut this off. This will be fun. Watch this. Bears, y bears, polar, r1. I wanted to go a negative bears, y bears function. Oops. Clear, bears, y bears, polar, r1. That's because I was too lazy to type negative that. And let's graph it. Nope, to graph the infinity symbol, I only needed one of the two. Isn't that cool? You don't have to graph the plus or minus piece. Okay. R equals 2 theta. Ooh. Now, this is pretty wicked because R is the square root of x squared plus y squared. Technically, it's plus or minus 2. Now, theta actually does equal inverse tangent of y over x, but this inverse tangent is fairly weak because of all the scribbling that we done. So, number one, I don't want to work here. It's disgusting. Number two, I don't think I can get y by itself, so I want to stay right here. Now, literally, it's as dumb as the theta r table, or an r theta table. Depends on how you want to go about it. But you know what? I like this. Clear, clear. 2 theta. Hit graph. Okay, it shot off my screen. So let's try zoom 6 maybe. Zoom 6. Whoa, spiral. Pretty nice, huh? It's called a spiral of Oops. Archimedes. Pretty awesome. Now, there's one more for sure I want to graph. It's r equals 5 plus 10 sine theta. So I'm going to go 5 plus 10 sine theta, knowing that sine goes between negative 10 and 10 and 5, so window about negative 20 to 20, negative 20 to 20 graph. Whoa, looks like a heart, it's like a hole, that it could be better known as the elephant butthole function. It looks like an elephant butt with a hole to me. It's called our cardioid dioid with inner loop. But the elephant butthole function sounds good to me. Okay. Now I see in the book they want to convert again. And I'm like, I'm not excited. First of all, I'll graph it. Oh, it's a parabola. Okay. We're going to get an upside down parabola, everybody. Hey, let's zoom in. Maybe we can find the... Oh. So it's like down 2 over 4. Okay. Okay, so it's like y equals negative something squared, x squared. All right, so cross multiply. You get r plus r sine theta equals 4. So that's the square root of x squared plus y squared. Technically plus or minus. Plus y. Oh, don't like that. Now let's go with it. Equals 4. Let's move it over. Plus or minus the square root of x squared plus y squared is 4 minus y. Now let's square both sides. And we get x squared plus y squared, because the plus or minus goes away, 16 minus 8y plus y squared. Y squareds go away. Let's pitch this way, this way, and we get 8y plus 16 minus x squared. Y equals 2 minus x squared for 8. And I prefer minus x squared over 8 plus 2. And by the way, when I was thinking originally, I knew it was plus 2 because it was upside down going through 2. And it turns out the mystery value was that 1/8. Pretty cool stuff. Now, you're not even going to be close to an expert at this. But you got to learn to get comfortable with polar. If I got more time, I'll spend more time here, because in calculus, they go right into polar. Keep in mind, you're not leaving the XY plane. I just given you more power to graph cool things. You can graph spirals. You can graph roses. You can graph elephant butts. You can graph elephant butts with holes. You can graph, I don't know. I think you can even graph, I think if you're smart about it, you can even graph, doesn't a marijuana plant have like 5 leaves on it? 5 cosine, 5 theta graph. Yeah, there you go. Graph a marijuana leaf if you want. Um, you can also graph all sorts of weird things. You can play around with it. It's like page 862 of your text, and you got all these formulas, and if you adjust the A's and B's and the N's and things, you can get some pretty cool looking shapes going. And remember, if you want to slow it down and make them look prettier, you go like 0.01, and then it just slows it down, and it graphs way more points. And you can see it graphing. But you would be surprised when you switch this. Oh, it's graphing again. You need to go all the way to 2 pi. I think when you switch it to a 6, it graphs 12 leaves. 1z, 2z, 3z, 4z, 5z, 6z, 7, 8, 9, 10, 11, 12. Pretty cool. That's it for the semester. There'll be more to come. I'll be working problems, trying to get you through to the end. Um, that's about it. Good luck. Let's finish this class off. No. Here we go. Oh, I did record it. Oh, thank you.